Let's begin with the session.
Sure. Okay. Go on.
So now the first thing, let's switch on let's start our DVWA instances.
You are sharing the screen, right?
Yeah, just a moment. So the screen is visible.
Sorry.
Hello,
Yeah.
the screen is visible.
Yeah.
Okay. So did you try these things out? The ones that we covered in class?
Haven't. Sorry, haven't.
Haven't. Okay, then do try them, because if then there's something that you may have doubts on, or something that you may have
Okay.
unclear, then you can find the right.
Okay.
So the next thing we're going to see is this weak session IDs. So for this, we're going to need our burp suite running. First, let me- Now, when I click on generate, then I'll get a request in my burp. And okay, so this is the request, and I need to tell it to elicit the response to this one as well. Or I can simply do, can send it to repeater. Repeater is also in burp suite.
Yeah.
And okay, so now this is the response that I got from the page, from the site, sorry. And the site has set a header called set cookie, and DVWA session, that's the name of the cookie, and the value is 1. So when I asked it to generate a cookie session ID, so it generated an ID, and the ID is simply 1. Now what I'm going to do is I'm going to go to repeater, and this is the request that we are going to repeatedly send now. So when I send it, this is the response. Now this time the session is 2. the session ID is 2. If I keep sending this again and again, you can see that the session ID is incrementing by 1 every time. It's simply 7, 8, 9, and however many sessions I generate, it will simply keep increasing the session ID by 1. And this is not, this is not an effective way to generate session IDs, because if I'm able to find out how it's generating session IDs, then I can gain access to other users simply by specifying a different session ID in my own request. Okay, I click on intercept. If I click on generate now, what I'm going to see is, okay, this is not using the session ID cookie, but an actual session. What it will do is, it will have in the cookie, it will have something like DVWA session is equal to, and whatever the value of that session is. Now if I can change, now since I have burp suit, so I can make any changes I want to the request. And if I change my session ID from 1, let's say I have my session is session ID 1, other users, there's a lot of other users on the website, everyone has a different ID, and if I change my ID from 1 to let's say 20 or 25, then I'll be able to run that user session on my system. So this is a very weak way, very insecure way to generate a session ID. Okay.
Okay.
If I go to use source, then here I'll be able to see that when it's generating a new session ID, all it's doing is simply taking the last session ID and it's incrementing that value by 1. It's simply doing that every time it wants to generate a new session. So that is all that is happening. Okay.
Yep.
And this is, as you've seen, this is not a very good way. If we change the security level for this, try seeing on medium. And we go to use source now. Cookie value is equal to time, simply. And what that means is, let's in above, click on intercept, generate, and okay, so from the last time that I had to generate session IDs, I was at session 29 because I had generated a lot of IDs before that, so it had put me at this session ID. Now I need to repeat again. Repeat is simply a tool that will allow you to repeatedly send a request, and if you want to make some changes, so you can compare what happens when you make those changes. Now I send this request, and this time see the DVWA session is, this is the ID now, and while it looks like it's a random value, but actually what is happening is it's simply setting the value of the current system time. It's taking that and it's setting this as the session ID value. So if I click, it simply keeps increasing by 1 second.
Oh.
If I click this twice within a second, it doesn't even increment. So let's say this is 50. If I click it now, then 6, since it's 6 seconds later, the value changes by 6. So they're simply setting the current time as the session ID value. So even this is not secure, because if I am able to figure out that this is what is being done to generate session IDs, then I can use this information get access to someone else's session as well. Let's see what they're doing when we come to high security. And what we're going to do is okay, so this time I'm getting a value like this. Okay, DVWA session is equal to, and this looks like a hash value. Okay, so if I click on send once more, I'm getting different value, which is which is very much different than the previous value. So I can't guess this value, but let's see whether this is secure or not. If I just copy this and then I open my terminal, click on hash identifier, try to see what kind of hash this is. So it says that it's possibly a MD5 hash. Okay. There's a lot of websites online that can crack MD5 hashes. So just found the value for this hash. So it's 7. Okay. So this is the hash for the number 7. Okay, let's see what happens when I try the next value. Okay, so let's try this hash now. And what do we find? This is simply the value for number 8. So even this is not secure, because what they're simply doing is that they're simply increasing the session IDs by 1 and taking the MD5 hash of those values.
Oh.
So let us check what the next session value is going to be. So it's probably going to be this. So it should be this 45C. It's okay. Let me just copy this. Okay. I click on send, and you can see that both these values are the same. If I try to paste it here, you can see that these values are the same. So this time they're simply incrementing it by 1 again, and they're taking the hash of that. So and that is a weak, very insecure way to generate session IDs. So if you find a website and it's generating weak session IDs, the algorithm is weak. So that is a huge issue with regards to security as well.
Okay.
Okay, so always this is something that developers should keep in mind as well. That session ID should be actually randomly generated, and they should not be easily guessable or something. Because if you guess someone else's session ID, then that is not that can be a huge issue for you, for the security of the website. Because if you are simply able to gain someone else's session, you can do a lot of malicious stuff on other people's accounts. Okay. So let's move on to the next thing now.
Okay.
So there's this vulnerability known as cross-site scripting. It is written as XSS, and it has three kinds: reflected, stored, and DOM based. So cross-site scripting is, in any website, see, there are three main parts. One is the layout or the content of the website, which you write in HTML. Okay. And the next thing is how the website looks or the appearance, which is written in CSS. And the third thing is the behavior of the website, which is controlled in JavaScript. So, cross-site scripting mainly focuses on manipulating the JavaScript in order to do some malicious activity on the website. Okay. So let's see how that works. And this is simply an input which is asking me. Oh, sorry, what happened? Okay, it's simply asking me what is your name. So if I try to insert a script here, a script tag. Now this is a tag in HTML, and whatever comes within this is a script. It's usually JavaScript code. Let's say alert 1 and submit. Then now what is happening is the script is running, and this is an alert that I'm receiving on the screen, and the value shown within the alert is simply 1. Now I could okay, normally you wouldn't use it like just to show a value on the screen, just like 1 or anything. You would use something like script. Sorry, the closing tab. So now this is showing the value of the cookie that the website has stored on my browser. So I notice one more thing, that whatever I enter, that is also getting included in the URL. This name is equal to this parameter. Whatever text I entered is getting included here. So how this can be exploited is, let's say you send this link, okay, and they click on this link. So whatever script you have written, it runs on the system, and you can use it to, let's say, gain some information about them, gain information about this session or about the cookies, or something like that. So this is an example of how cross-site scripting works, and it is a very serious issue in any website.
Okay.
And the way to exploit it is to get a script to run in any input field. So as a developer, if you think about it, you need to always validate or check what kind of input is coming in from an input field. And there are some validations that are applied in DVWA and higher security levels. Let's say you go to medium, and let's try to, okay, first let's go to low. There's other kinds of tags that can run as well. Like currently we tried the script tag. Okay, you can also use this image. You can use the image tag. So image source is equal to, and just type x no source, and on error is equal to alert document. So if there's an error in loading the image, I want this code to run, and this is simply again going to give me the cookie value. So this is another tag that can run there. or I could use something like body on load is equal to alert, and this simply means that whenever the page loads, when body of this page loads, it is going to run this code. So it alert gives me an alert. If I go to view the source code here, what it's doing is it's taking some input, and the name of that value input field is name, and it's simply printing that on the screen. Whatever is the input, it's simply displaying that on the screen. And let's try changing the security level here. So, medium. Let's go again. Let's try running these script tags. So you can see it does not run now. Tags that I'm using, the script is not running. It's simply taking that value and it's displaying the value that was inside the script tags, right? So let's see what modifications they have made in the source code this time. So we can see that they've added this part, name is equal to string replace, and whenever they see the script tag, whenever they see this value, they're replacing it with an empty string. So they've added some basic filtering, and if a script tag is written like this, then they can filter that out. But there are ways to get past that as well. Okay, what if I were to write script in capital? Yes, both script tags are in capital now. Let's see. So that is something that they're not filtering, and I can easily run this. So there's a lot of options for what kind of scripts you want to run. The other stuff that we saw, this image tag and stuff, that is also going to run because they haven't added any sort of checks, any sort of filtering for this. And the thing that we just saw, that they have filtered this. So if you type this kind of script tag, it will get filtered out, but we simply change the case and then the exact same thing. So this is, these are some kind of things that you may need to try out at various times. Like, okay, if lowercase is not working, what about if I try uppercase? If something is blocked, then I can try various variants of it.
Okay.
Similar to what we saw in the file inclusion, right? When // was blocked, so we thought, okay, if I did this 2 times, then I will be able to use that. Right? Do you remember that part?
Yes.
Yeah. So that is the kind of that is the thinking you need when you come across these things. That okay, this doesn't work. Maybe let's try this. If one thing is blocked, then maybe another state of it will work. So stuff like this. Now let's see what happens if I go to high security. Let's see what changes they made to the source code this time. Okay, and replace. So script tags are not going to work at all. Let's see. Does this kind of thing work? No, that's not going to work. But we have other alternatives. Let's see whether those work. So this works. If you're talking about cross-site scripting, or if you're talking about SQL injection, if you're talking about any of these vulnerabilities, if one payload doesn't work, if one code doesn't work, then you have a lot of options, you have a lot of things, and there will be a lot of cases where developers block one thing, but they don't block the other. So you can in more cases, more variants of, you can find different payloads that will work. You can try different things. And okay, currently we're just, we're just studying this, so we are able to view the source code because they've provided us. But in an actual website, you won't have access to the source code, so you won't be able to see what kind of filtering is applied. So you need to think of various payloads. You need to think of, okay, if this one attack doesn't work, maybe I can craft it differently. Maybe that will work, stuff like that. So this was reflected cross-site scripting. Reflected simply means that, you try to do some cross-site scripting, write a script, and it runs once in either, whoever you are targeting, runs once in their browser, and it may give you some information, or it may perform some action on their behalf, or something like that. But another type of cross-site scripting, which is more dangerous, is stored cross-site scripting. And why is it called stored? Because this happens when you're able to store your cross-site scripting code within some database on a website, and the contents of that database are then accessible to anyone who visits that particular website or that particular page. So I'll show you how this, what that means. I just need to reset the database once, so because there was a lot of data there which I need to remove. So let's go to the DVWA security part first. Change it to low. Okay, so this is an example of, when you're adding, let's say, a message, when you're adding a comment on something. Let's say you see a blog and you're adding a comment. So what are the two things that you need? Mainly your name and a message, whatever message you want to write. But since we are trying to see cross-site scripting, let's see. So there are two input fields in this case. One is the name field and the other is the message field. So right now we don't know which of these fields is vulnerable to cross-site scripting. So let's try out both of them. Okay. So you see that we're not able to type anything else because it has a fixed length. It has, a maximum number of characters, and I think we reached that maximum. So we can't type anything else. Okay. So let's just try doing the cross-site scripting in this field. I click on sign this book. So now what happened was that field was vulnerable, and instead of the message appearing here, it contains our cross-site code. Anyone who accesses this link will be able to see this. Now let's say if I go to some other link and if I go to this page again, then this will run every time that this page is accessed. And whatever, whoever accesses it will see this cross-site script. So stored cross-site scripting is much more serious, much more critical than your regular reflected cross-site scripting, because stored affects a large number of people than it, because reflected will only run once in whoever's browser you send the link to. But stored will run for everyone who accesses that.
Yeah.
Okay, so now let's try it on higher levels. So again, you can say how as many times I open this page, this alert is going to run. And again, this has a maximum limit of characters, so beyond that we can't enter. Let's try again. Okay, so this time it didn't work. The one that we saw earlier was from the previous example. In this example 2 that I used, the cross-site scripting didn't work. It simply showed me this text. Let's see why that is happening. So the first thing we need to see is we have two inputs this time. The first is the message and the second is the name. So this is the message, this is name, and this is the source. Okay. So this is what they're doing is simply they have applied the HTML special characters function to this message text. So what that does is it removes all the special characters from whatever input is coming. So in this case, we have a limited number of characters in the name field, and the message field does not have that limit, but it has it has a filter for inputs. So do you know what we can try in this case? Okay, let me show you what we're going to try. So we're going to I'm going to press F12 and this will bring me this page. I'm going to inspect element. I'm going to click on this name field and see this is highlighted here. So in this field, see closely, there is this value called max length. Okay. So and 10. So I have a maximum of 10 characters here. What I can do is I can simply remove this field. Now I can try to enter whatever I want. Let's say I try to enter this tutorial document.cookie and whatever I want, random text for the message. So I click on sign guestbook now. So now this script is running. It's giving me the cookie value. Document.cookie is running. It's giving me the value, and okay, so it was not accepting any input greater than 10 characters. So we simply remove that parameter for this, and okay, these changes will only work on as long as it is open on system. So this will only work on the client side. It won't alter the actual page on the server, but we need to make this change only to enable the field to accept an input greater than the 10 character limit. We can also probably try another method for this using a notebook suite. So what I can do is I can write simply write nothing here. And okay, let me do one thing first. Let me reset the database so these values get removed. Okay, so let's go back. And what I'm going to do is simply intercept. So text name is equal to this, message is equal to this. So I can simply try to do this. Okay, so text name is equal to, I can simply try to change that value. Do some tag. Okay, so this method won't work here. Okay, but we can do this, changing the maximum length limit for this, and write whatever we want. Let's try changing the security level now. So let's see what's happening in the source code this time. Okay, let's try it again. Simply use the same thing. Or let's say I try to do this body on is equal to alert whatever random. Let's say so this is working now. Again, we are able to do this. Can I do the same thing with a script tag? Let me check. If I try it using a script tag, that is not working because they have applied some input sanitization in this case. But there are, like I said, there are lots of different payloads when you're considering individual vulnerabilities, so you can try different ones.
Yes, correct.
So now, since this is stored cross-site scripting, so and if I come back every time, whatever successful cross-site scripting code I was able to store in this database, it will run every time I come to this web page. So you can see how this is more impactful or more critical than a reflected XSS. Are you able to get the exact difference?
Yes, I understand.
Okay, so this stored XSS is much more dangerous. Now there's another type of XSS which is called DOM based, and for that we need to see what the DOM is. DOM stands for Document Object Model. So that's basically a hierarchical. So it's basically a structure, basically a hierarchy of the web page. If you look at the definition, it says that it's an API for valid HTML and XML documents. So I think it will be more clear to the diagram what XML is. So whenever you go to a web page, so you consider the entire thing, the entire web page as a document, and whatever elements are a part of that web page, whatever whatever code, whatever HTML, whatever CSS, all of that is a part of this. Is a part of that document, is a part of that web page. So DOM is a way to represent a hierarchical structure of that thing. Like let's say you have a table. Okay, let's say you have a table in your page. So right now we're not considering the entire web page. Let's just consider that particular table, which is a part of the page. So the table consists of various rows, and the rows consist of different TR elements. This is TR is HTML for table row, and so they have their own then TD elements which have the individual values. I think this not okay. Now your document, your web page, it consists of the entire document. That is the base of this DOM. It consists of various parts, like your root element is HTML. So the HTML consists of a head and a body. Then the title consists of the title element. So the rest of the title element, and whatever text is a part of that title element. Then within your body, where you have the main HTML code, that in this example they've only shown a couple of things to make it simpler, but most of your website code is within the body element, and it can contain links or href attributes. It can contain anchors. Anchors contain links. It can contain your headers, headers like h1 to h6. Then the header contains the actual text. Then your anchor element contains the actual text contained within that. If I click on view page, then this is the HTML document. Sorry, this it contains of a head. Then a head contains of a lot of stuff like meta tags, links. It even has a style sheet right here. And it contains your scripts. It loads scripts from various sources. Then there's the body of the HTML, which contains the major code portion. So basically, DOM-based cross-site scripting is a way to inject your cross-site scripting such that it interferes with how the DOM elements interact with each other. Let's see how that works here. It's a simple list of 4 languages. It's telling us to choose a language. So what I'm going to do is I'm going to, let's say, select English, and you can see what changes it's making to the URL. Okay. Currently it's simply this vulnerability is XSS_D. Click on select, then it adds a parameter. Default is equal to English. And what if I add my script tag here? Okay, this is actually an extension on my browser. So I am able to run a cross-site scripting attack by just simply changing the value. Let's see what happens when I try this on a higher security. Yeah. Can I run this now? Or can I run some other tag now? Let us try. Okay, so it's not running anymore. What we can do is we can add an anchor tag. So what this does, okay, so this kind of script maybe it won't run. Let me just try on scripts. So again, I'm able to run this. So this is basically, we've covered cross-site scripting today. And the next thing we have is Csp Bypass. So now there's this thing known as the Content Security Policy, or CSP, and we want to see what that is. It's basically an HTTP header which is set by the server, and I'm going to use my burp suit now. Let's just say I enter whatever value here. Right now what I'm going to use, I need to find information about what kind of CSP is being used. So okay, so this is the response I'm getting from the web server, and these are the various headers. One of them is Content Security Policy. Now this header, what this means is, see, a website, it has a lot of resources, like it may have images, it may have some CSS, it may have some scripts, and it can load these from a lot of different sources. Like let's say it can load an image from some other website, it can run a script from another website, or all of the resources that it can possibly take from other websites. If I'm using the Content Security Policy header, I can define what sources are allowed for my website, for the web page, to load resources from. So if I know that some resources, if I know that some website is malicious or harmful, I'm not going to allow my website to load its resources from there. So in this case, what this parameter is, script source. So this parameter defines where the website can load its scripts from. So it can load its scripts from self. So that is scripts that are originating from the same domain, which are part of the website's code or are a part of the same server. It can load its scripts from pastebin.com. It can load scripts from example.com, code.jquery.com, and ssl.analytics.com. So these are the allowed sources from where this website can load its scripts. Okay. So Content Security Policy defines where a website is allowed to load its resources from. Okay.
Yep.
I'm going to turn this intercept off now. If I click on View Source, then simply in the View Source part, they've simply mentioned this header CSP, and in the comment they've also mentioned that it allows JavaScript or script codes from self, pastebin.com, jQuery, and Google Analytics. So, and what they've done is basically they themselves have made a script and they have posted it on pastebin.com, the creators of DVWA. So we can just if I use this sorry, not this, paste this here. I click on include, then it's going to include that script, is going to load that script from pastebin.com, and it's going to run that. And what the script does is simply alert pastebin. So this is also giving us an alert. If it could have anything, it could have alert document.cookie, or it could have some other malicious JavaScript code. But since this website, pastebin.com, is a part of our CSP, our Content Security Policy for DVWA, so the script uploaded from this website will run easily. Okay, so that's why you need your CSP, your Content Security Policy, to be very strong. You need it to include whatever possible, you want to keep it as as compact as possible, so that you don't have a large variety of sources, just from itself or from itself or one or two ways. That's it. Okay. So
Okay.
were you able to follow along everything that was taught? Like, are there any doubts? Is there something you would like to clarify?
No, all clear. Actually, I understand almost everything. Maybe this 1 2 days. Once we finish this, maybe we can go through hands-on session. Maybe.
Okay. So you're able to understand, right? There's no issues
Yes,
there.
yes, yes.
Okay,
I
that's
don't
that's good. So now we'll see more in the next class. We also currently have SQL injection left. There's a couple of things in JavaScript that's left here, and we'll cover all of that.
Mm-hmm.
So we have our next class on Thursday. Okay.
Thursday. All right. Cool.
Yeah.
Okay.
Okay. So I'll see you then on Thursday. All right.
Okay.
Okay then. Bye.